Hi, and welcome back to Null Zero Labs. Today is going to be more of a learning journey. It's going to be a long one, so strap in, like and subscribe, and get your coffee ready. We're going to have a blank canvas, and I would like to build an Arista multi-chassis lag setup and connect three what would be the equivalent of three top of rack switches that would be lagged back to this multi-chassis setup, which we could class as, like, say, our end of row switches. I would like to get that all set up and have a single VLAN and have three nodes connected to each one of those switches at the top, in the top of rack, and have them communicate with each other through their VLAN. I would then like to see about creating a management-vrf that we can access that is separate from the main traffic flow. And then I would then like to look at then removing one of those top of rack switches and replacing it with a Juniper device to slot in and take over from the Arista. So it's going to be a little bit longer than normal. We're going to have to look up some commands to refresh the old noggin up here of some of the syntax. But hopefully by the end of it, we should have created a multi-chassis lag set up with Arista, and then learned how to swap out one of the Arista switches with, say, a Juniper device, and allow the clients to continue talking to each other and have all of the management interfaces of those devices being able to see each other from a management desktop. So that's the plan. So let's jump in the lab and let's get started. So here we are in the lab. It's empty. Normally we have something here. So we're going to wire this up together, and we're going to get it all working together. So follow along. I may go quiet a couple of times throughout this video whilst I look up a syntax or a command that I've probably forgotten. And we will hopefully get the first stage complete of two Arista switches that will act as our end of row aggregation, and then from those switches we will connect to three top of rack Arista switches that will be connected back using lags to that multi-chassis setup. So that is the plan of action. So I am going to drag in some switches. So we need some nodes to start with. So Arista is what we want. We want a switch. We are going to need 5 of them. 9 ports on each. We're going to use 1, 2, 3. We're going to use 4, 6 on each, and a management port should be enough. That should be enough for what we require. So we'll move these out of the way. So we're going to concentrate on our multi-lag setup first. So these will be our redundant chassis setup. So we're going to need a connection between the two of them. We will use 7 to 7 and 8 to 8. This will be the equivalent of what we're going to use for our peer link between the two devices, like how we would in a Cisco world. We're then going to need a management connection because we will need to use it for some heartbeat stuff for split brain, although we can't really demonstrate that here because the way Eve keeps some of these interfaces up, we won't see the split brain test. But the purpose of having obviously the management out of band management network is so that you can manage the devices out of band, but also we can use them as a heartbeat network, so that if these links for the peer link ever go down, then the switch that is the secondary, from what I can remember, will then shut down its interfaces that are in the lag group, apart from the ones that are going towards the peer, so that there won't be a split brain scenario. So we're going to need this for management and also for that additional heartbeat setup. So that's that. These little management clouds, this will connect this PC into the management network, so I don't have to run a cable up there, etc. So we've got our what's going to be our core or our aggregation chassis. We're then going to need our 3 top of rack switches, which again are all going to be Arista. Switch 3 and switch 4 are going to have a 4 gig lag. So we need 2 connections from each. So that's our lag, is going to be our lag there. We'll do the same for 4. 4 is going to be a 4 gig lag. So it's going to go E1 to E3. It's going to use 3 and 4 on each of the chassis switches. So 3, 3, 4, 4. And this one, we're just going to do a standard 2 gig lag connection. So that's the wire up for that. So these are all going to be, our trunks down to our access switches. So what we also need now is a couple of nodes, Linux nodes for testing. So we'll call these our nodes. We will use our server node. Connect that up on E5 on each switch. I forgot to select a multiple. So 2 more of those, please. Save. Connect that up on E5. Connect that one on E3 on this one. So that's that. And let's just change that network interface card to the E1000. E1000. Save. Okay, so let's look at what we've got. We've got the equivalent of what we're going to build here. So if let's take a circle. 20, 230. Color preference of choice. Let's take that circle. Let's edit that. Transparency. So what we are technically building is a let's rotate this slightly to a, say, 45. Save. So we're going to create what is effectively from this switch a port channel, a pretty standard port channel because it's a single switch. But obviously, as we know, these are 2 separate switches, so we have to use the multi-chassis technology, or in the Cisco world, the virtual chassis, the VPC setup. So we're going to do this in the Arista format so that we can understand it and see how it all works. And then we're going to, like we said, we're going to swap these access switches out for Juniper ones and get all of those up and working. So let's start with all of our nodes and get them all configured, because what we will do is let's duplicate this. We'll bring this over here and Control A. 192.168.51. This will be 1/24, and it will be in. Let's do a VLAN VLAN 51. We'll duplicate that. This will be .2. And we'll have this one over here, and it will be .3. So those are our 3 nodes in 3 different cabinets, and we're going to want them to have a switching fabric and be able to communicate with each other. So let's get these all nicely laid out. There we go. The OCD is kicked in. Now let's just lock that so it doesn't start moving around on us. Let's start up all the nodes and get those configured. We're going to change the net plan and assign those IP addresses to them. Obviously, they won't be able to ping each other, but we can make sure that they can ping themselves and we know that they are online. We'll then configure the Arista switches. That'll be the simpler task because we know it's just a standard port channel. So it should be very similar to what we do in the world of Cisco. And then we'll finally come up to the top layer and we'll bring it all together so that everything all functions. What I will do is we will use a cloud so that we don't end up having to run all of these cables over here and it starts to get messy. We will wire up a management interface to each one of these switches as well, so that we can check that our out-of-band management network can have management access to all the devices. So let's add a network. Let's use Cloud 1, MGMT. Connect its management port. So this is just a fancy way of EVE-NG being able to wire it back to that switch because the switch is connected to that management interface. And again, let's add another one over here. Cloud 1, management. And we'll plug you on this side. So there we go. So we have our 3 cabinets and we have our end of row aggregation using Arista. So let's log on to all of our Linux nodes and get those online. Right, so here's our Linux nodes. So the first one is just called nodes. So null 0 labs, password test 1 2 3. Obviously don't use that, use something far more secure. Sudo nano / etc net plan and press tab. We should find what the file is that's created in there. Test 1 2 3. Right, I've pre-configured this slightly, so I'm just going to turn these off. Typo. So name servers, default gateway, IP address 192.168.51.1. DHCP will be false. Control X, yes. sudo net plan apply. Oh, now there's 2 ways of what I've done wrong here. I can either put square brackets around this, or I could have come down and done like the hyphen and then I prefer the square brackets. Apply. Okay, IP ADD. We can see that ENS3 has got its IP address. Let's just check to make sure the stack's working. 192.168.51.1. It can ping itself. That's all functional. So that's the first one done. Second one is node 7, and that's going to be .2. So same again, we're going to edit the net plan. Now we will set this to false because we're not using DHCP. We will put the brackets around this. This will be 51.2. And the rest of the configuration will be the same. There was a typo I put here, so I will fix that so it doesn't error. Now we can delete all of the comment lines, bring that up, sudo netplan apply, IP ADD, that shows us the IP address. We can see that the IP address is there. Make sure we can ping ourselves 192.168.51.2. We can. Obviously, we won't be able to ping 51.1 because we haven't configured any of the switching yet. So our final node. Knowledge via repetition. So we should all know it by now. Sudo /etc/ netplan. Help if I typed nano for the editor. There we go. Test 1, 2, 3. Turn off DHCP. Fix the typo. It's node 3. Fix the typo and uncomment. Okay, Control X, save, sudo netplan apply, IP ADD. I've got this urge to always type show IP for some reason on a Linux CLI. So there we go, it's 53, ping 192.168.51.3. So we can ping ourselves, we know our networking stack is functional on the server. Good. Now let's bring up our 3 cabinet switches. So we're going to start these all up. These are going to take a little while to boot up. Okay, they are up. And what we're going to do first is we are going to log in and we're going to disable zero touch because we're not using it and it will keep trying to interfere. So we will disable that. They will then reboot. We'll do that for all of them. Zero touch disable and switch 5. Admin. Zero touch disable. Okay, so now we'll let these all boot back up and then we should be able to log in without zero touch configuration pestering us endlessly. So like I said, we'll let those boot up and we will then do the creation of VLAN 51 on each of the devices. We will create the access interfaces towards our clients and then we will create the port channels towards our aggregation. And we will allow VLAN 51 to be carried on that. We will then set up the management interfaces and get management access to test to make sure that we can reach them from the management desktop. Cool, looks like we have got our 3 devices online. So let's start with the first one on the left, switch 2. So we're going to log in. We will worry about securing it later. So it looks like yes, en is the command. Okay. Let's let me bring that up a little bit so that we can see. So host name, let's just call it SW3 so that we don't lose track of where we are. We need a VLAN, so I suppose it should be VLAN 51. Okay, give it a name. VLAN 51. Cool. So that's the same. So int E5. Switch port mode is going to be access. Switch port access is going to be a VLAN 51. Spanning tree. Port fast. Port fast edge. No shut. Let's have a look at what we've got. So we've got our interface 5. We've made it an access port. We've done port fast edge because obviously it's just a client device, and we've created our VLAN. So that looks all good. Let's create our VRF instance. Okay, we'll just call it MGMT. Okay. Show interfaces status. That's management. Okay, so in management 1, VRF management, IP address 10.255.255. We're going to use 1 and 2 up on there, so this will be 3. Can we use CEDAR notation? Yes, we can. So VRF is management, IP address. We may want to be able to do routing later. So if we go config T again, IP routing, VRF management. So we turn it on, and then if we go IP route VRF management, the default, let's just say it'll be 10.255.255.254. Okay, that works. So we have our default gateway for our management network. We have an interface in the VRF. We have VLAN, and we have our access port. Okay. Show VRF. Okay, show IP route. So the main routing table is empty, VRF is default. So show IP route VRF management. Yep, it has its default static configured. Okay, so far so good. Now let's do 1, 2, 3, 4. So they're all going to be in a port channel. Config T. Int E1 to 4. That's nice. Okay. Is it just channel? Oh, yeah, channel group. Channel group 1 mode active. Cool. In PO1, switch port mode is trunk. Switch port trunk allowed. VLAN is 51. No shut. Show right. Is that it? So we got port channel. It's configured as a trunk. We're allowing 51 on there only. We've assigned E1 to 4 as part of port channel 1. We've got our access port. We've done our management interface. We've set up our default route for our management network to our gateway if needs be. What else would we need? To secure the login. So config T, username. Let's go null 0 labs. Privilege. We've got a level 15. Secret. Unencrypted password will follow, and we'll put the password as null 0 labs. So null 0 labs, null 0 labs. Cool. Let's exit that. See what happened. Admin. Nope, it was null 0 labs. And I've just noticed something. Null 0 labs. So that did create that. Okay. But I didn't secure admin. So user admin secret 0 null 0 labs. Let's test that. So admin null 0 labs. Cool. Okay, so we've secured it, we've created the management, we've set up the trunk, we set up a device in the access port. So let's write that. Okay, let's jump on to switch 4 and we'll do the same. Admin again, enable mode, config T, host name is SW4. I'm really starting to dislike this Apple keyboard. So we've got our name. We're going to go VLAN 51. Name is VLAN 51. Int E5. Switch port mode is access. Switch port access VLAN 51. Spanning tree mode. Fast edge. No shut. We need a port channel, so int range. We don't have to use the range command, so it's in E1 to 4. Channel group 1 mode active. Int PO1. Switch port mode is trunk. Switch port trunk allowed. VLAN is 51. No shut. Okay, host name, VLAN, port channel. Put those all in the channel group. Access port management now. So VRF instance, MGMT, IP root, routing VRF MGMT, IP, so int, what was the management? Int management1 VRF. It is just put it into the VRF, isn't it? There's nothing special we have to do for that. So it's just VRF and the name. Yep, so VRF management. IP address. We said 10.255.255.4/24. Make sure that's not shut. And then IP root VRF management is 10.255.255.254. So management, default route for the VRF, access and trunk port done, VLAN done, set the host name. Now we just need to username admin, secret is null 0 labs, and we set a username of null 0 labs, privilege level 15, secret 0, and the password was null 0 labs. So the root, that all looks good. Let's do a show IP root. Nothing in the default table. Show IP root VRF management. Yes. show IP int brief. Is that? Yes, management interface is up. Show int status. Those are in the port channel. That is in VLAN 51. That is up, but obviously not connected at the moment because we haven't done anything above. So that looks good. So we'll exit that one. Now we'll look at switch 5. Less ports on this one. So admin, config T, host name is SW5, VLAN 51, name VLAN 51. That will do. Int E3 on this one. Switch port mode is access. Switch port access is VLAN 51. Spanning tree. Port fast edge. No shut. So int E1 to 2. And then go channel group 1. Mode will be active. So that'll be LACP. Int PO1. Switch port mode is trunk. Switch port trunk allowed VLAN 51. No shut, just be sure. Actually, so if you went switch port mode trunk and you went allowed, is there an add? No, so you don't have to worry about that. So not on the world of Cisco where you'd have an interface where you've got this command set up, you'd either you really do have to remember to say add. So it's not VLAN. If we go VLAN, VLAN add. Yeah, so it does have it. So if we're going to add a VLAN later, we have to remember to use the add command. Otherwise, you will lose all the VLANs on there or lock yourself out. So yeah, one thing to remember when you're adding VLANs to a trunk that is locked down, always use the add command. Right, so show run. What have we got left to do? Let's do the username and then we'll do the VRF. So username is admin, secret 0, and username null 0 labs, privilege level 15, secret unencrypted null 0 labs. VRF instance management int management 0. Nope. In management 1. Nearly made a mistake. VRF is management. IP address is 10.255.255.5/24. IP routing, VRF management, IP route, VRF management, destination, um, 10.255.255.254. So we have our management. Let's get rid of that because that shouldn't be there. Show run. Okay, so we have our switch name. We have our VLAN 51. We have our management instance. In the VRF, we have our port channel. We have our two physical interfaces assigned to that port channel. We have our access port in VLAN 51. We have our management interface configured. We have our default route for later if we want to reach the management network from another subnet. So that looks all good. So what we can do now is we can see if we can ping 10.255. If we ping via the VRF management 10.255.255. Which switch are we on? 5. So if we ping 5, we can ping ourselves. Switch 4, we can reach switch 4. Switch 3, we can reach. So the management VRF we've got reachability across the 3 there. We'll start this one up. We'll start this up and we'll check that the rest of the management network and the management PC can reach those as well. So let's start that node and we'll start the management PC because I did give that an IP address already. So if I duplicate that so we can remember what it's called, I think that is 255.10 just for rememberability. So once that comes up online, we should be able to go ping from the VRF and ping 10. Yeah, we've got the response. Perfect. If we open that desktop, test 1, 2, 3. We should be able to make sure that we can ping all of them. So ping 10.255.255.3. That one is up, yep. So management 4, 5. Don't think we set up any SSH, so we'll have to have a look to see how we set up SSH for it as well. So SSH null 0 labs at 10.255.255.3. Oh, so we might have to clear the hosts file. So let's clear that. cd dot colon. Oh, it's the tilde command, isn't it? Where are you on this keyboard? There, slash there dot SSH. That's the one I'm looking for. Let's just delete it. RM known hosts. Now, if we do that again. Okay, null 0 labs. Cool. We are into switch 3 from the management network. Cool. So we have management access from our management desktop to our 3 management interfaces on our 3 switches. We have our port channel configured on each of our switches and we have our access ports. Now let's get our aggregation part set up and where the most complicated part's going to be, and set up our multi-chassis lag, and then check that we have reachability across the fabric for our nodes in VLAN 51. Check that we can reach the management interface, and then we'll do some packet captures and see what's going across this peering link. We'll shut one of these down and we'll see what happens to the traffic flow, how long it takes for the device to recover and traffic to carry on functioning again. Oh, and we're back. So these have booted up. So let's start with switch 1 here on the left. Let's drop down a little bit so we can see all of our links that these switches have. So on this one on the left, SW1, so admin is the default. Let's set the host name to start with. So the host name is, I'm going to call this mlag-SW1. So we know that it's different. We are going to set up this management interface first. So we wanted a VRF instance management and int management 1 VRF management IP address 10.255.255.1/24. So nice just to be able to put the slash in, no sharp. So that's the management interface. IP routing VRF management, enable it. IP route VRF management. The default gateway is going to 10.255.255.254. What's that? So it's our management interface, ping, VRF, management 10.255.255.10. It's our management desktop. Yes, it can see it. That's all working. Good. So next, let's do our, so we've got our management interface, we've got our host name. Let's do our username and password. Then we will go and have a look at the documentation and see what we have to do to set up the chassis side. Or maybe we'll set up both sides and get the management interface parts done, the host names done, and get those all functional, and then we'll set up the chassis side. So let's do our usernames that we need. So username admin, secret 0, null 0 labs, and then username, we wanted our backup username of null 0 labs, privilege level 15, secret unencrypted null 0 labs, well basically plain text entry. So that was that. We can create our standard VLAN 51 because that is required but not part of the MLAG setup, but we will need it to be allowed on the trunks. So name was VLAN 51. So that's our management function set up. We secured the device with username and password. We set our host name and we put in place our VLAN 51. So that's all good. Let's go over to switch 2 and do the same. So we're going to log in. Okay, host name is mlag-sw2. And then username admin, secret 0, null 0 labs. Backup username 15, secret. Obviously don't use that as your username and password. Think of something much more secure. VLAN 51 because we are going to use that, so better do it now so we don't forget. Give it a name, VLAN 51. Now let's do our VRF for our management. So VRF instance management. Cool. In management 1, VRF management. IP address is going to be 10.255.255.2/24. IP routing, VRF management enabled, IP route, VRF management to 10.255.255.254. And that should be our base skeleton code that we need. Back over to switch 1, the one on the left. Double check. Yep, that's all good. Let's check as well on switch 2 actually. So ping VRF management 10.255.255.1. So we can reach that. We can reach 3, we can reach 4, we can reach 5, we can reach 10, which is the management desktop, and 11, which is the management switch. So all the management VLAN is up and running, and the management VRF is completely segregated from the traffic flow that would be going over the switches. So now let's have a look at the configuration and see what we need to start with. So we're going to configure the peer switch port channels, which is obviously going to be this port channel between switch 1 and switch 2. We're then going to create the peer switch SVI, which is obviously used for communication between the two nodes, I suppose. And then we then have our peer links that we're going to configure. So we have our peer address, I'm going to create a special port channel for the peering links and put the peering links in the port channel and create an SVI. Whereas like I think normally when we're on a Cisco VPC, we'd have 3 connections, one for the peer keep alive, which does all of that communication, and then the other one which is carrying like all the bum traffic. So let's bring up switch 1 and let's have a look. So we're going to create the switch port channels. Okay, so we're going to use 7 and 8. So config T. So int E7 to 8. I'm going to create a channel group 101 mode active, just like what we did the standard one. I'm going to change into interface port channel 101. We are going to create a trunk, switch port mode trunk. Yep, pretty standard. This is a new one, switch port trunk group peer trunk. Okay, accept. And then on the other side, we're going to do the same. So config T in E728 channel group. We can do 201 over here, or what do we use over here? 101. Let's do 201 to show that it's the channel group from the other side and show that it doesn't matter about the channel group names. They don't have to match on either side. So channel group mode active. And then in port channel 201, and switch port mode was trunk. And then we added this switch port trunk group. We called it the peer trunk. Okay, let's go and look that up. What does that do? Let's look that up. What do you do? So switch port trunk group command on Arista is used to restrict VLANs to a particular trunk port. Okay. Enabling better control over VLAN propagation than the default all allowed. So if we was to create a trunk and then put a trunk group on there, we can then say what VLANs are allowed across based on the trunk group. So we can add the VLANs to a group. This restricts VLANs assigned to the group to the port channel interface. So okay, so they can only go over that interface. Okay. Now we need to create some SVI interfaces. So we're going to create a VLAN. So, and again, you could use VLAN interfaces, or you could use a no switch port command or a management interface on the Cisco VPC and connect them that way. So this way they're doing it with an SVI. So VLAN 4094, right at the top of the range. So we're creating a VLAN and then trunk group, trunk or peer trunk, wasn't it? Peer trunk, wasn't it? Yeah, peer trunk. Peer trunk. So we're assigning that trunk group to that VLAN, or that VLAN to that trunk group. And now we're going to create an interface for VLAN 4094. Okay, now we're going to give it an IP address 10.254.255. We're using 255, we'll use 254.1/30. That gives that an IP address. Auto state, so it stays up. and no spanning tree for VLAN ID 4094. So let's have a look at what we've done. So we've created an SVI interface for, this is obviously going to be for the communication between the two chassis. We've created the VLAN, similar to like how we did there, but we've assigned it to part of this peer group trunk. And then on the inter-chassis interface port channel, we're saying that only that group is allowed to go across the trunk. What else do we need? Now we're going to create the peer. Let's do switch 2. So on switch 2, we've got the channel group and the channel group trunk set up. So now we're going to create the VLAN and the VLAN interface. So it was VLAN 4092. So I'll take that from that side, save me typing it again. So VLAN 4094. Trunk group is peer trunk. Make sure we did spell that right. Peer trunk. Yep, so it's all the same. And then we need an SVI. And we'll give it .2. 2/30. So show run. SVI interface, peer switch SVI is in place. This one is .2. We have the port channel and we have the VLAN. So next we need to configure the actual peering between the two. So let's start on the left in switch 1. So mlag config. So the local interface is going to be VLAN 4094. For some reason I want to keep saying 4092. The peer address is going to be 10.255.254.2, which is obviously switch 2. The peer link port channel that we're using is 101 on the left side. The domain ID, so again, we need a domain ID. We'll just call this mlag01. And heartbeat interval. What's the range? Let's go 1500. Seems quick enough. A reload delay of, what's that in? Seconds? Okay. 150 seconds, that's quite a long time. Keep non-peer links disabled after a reboot. Let's go 120. Okay. Now I suppose if we jump over to switch 2, we're going to do a very similar. So configuration or mlag configuration, mlag config. And again, the local interface is 4094. Peer address. Oh, why have we got invalid there? Show run. 4094. Interface 4094. mlag configuration. Local interface. Our VLAN 4094. Okay, good to know. Our peer address is going to be 10.255.254.1. So the one on the left, 10.255.254.1. The interface, the peer link port channel we are using is, where are you? 201, wasn't it? And then the domain ID was mlag01. Take it this is going to have to match mlag01. And then we said the heartbeat interval was going to be 1500 and the reload delay of 120. So that should be it. So now if we do a show mlag config sanity check, 4092 VLAN attribute is disabled. Inconsistency. We didn't disable spanning tree on show run. So we did on the left, we created the VLAN. We also did no spanning tree for that VLAN. Okay, so we copy that, bring this over to switch 2. Now if we do a consistency check, everything is all consistent. Check on the other side, show mlag consistency. Yep. Show mlag detail. So switch 1. So mlag detail. So domain, the local interface, the peer address, peer port. This heartbeat one we're going to configure in a minute. It's for the dual primary detection, but obviously, like I said, I don't think we can test it here because there's no way for me to bring these down and for the two virtual switches to see the interface actually go fully offline and it doesn't actually function. But in the real world, if we was to like cut these cables, if we don't enable this, both switches will keep their interfaces up and you'll end up with a split brain. The whole point of this extra heartbeat over the management interface is so that in the event that this link does ever break, because sometimes this might be not directly attached, it might be over a network, or it may be off a cross connect and off somewhere else. So if we break this, the heartbeat interface will see, hey, yes, that has gone down, but both switches are up. The actual switch hasn't gone down. And then that way, it will disable the interfaces on the secondary device. Like say, so this one here, switch 1, is listed as the secondary. And now it's listed, don't think of it as primary and secondary. It's both an active technology. So you don't need to worry about which one's the active and which one's the primary. It's just telling you that this one is operating in a secondary state and this one is operating as the primary. They'll flip-flop based upon which one is up or down. But the lowest system ID is the one that will normally become the peer primary. And in this case, it's based on the system MAC address, and the system MAC address on switch 2 is lower than the system MAC address on switch 1. So it has become the primary and switch 1 is the secondary upon boot. So everything seems to be up there. So we've got the basic MLAG configuration. So now we just need to create the port channels down to our access switch. So if we look, switch 3 is using E1 and 2, E1 and 2. So on switch 1, I suppose we are going to create, so config T in E1 to 2 on the left. We're going to create a channel group, same as what we did before. We'll call this channel group 1, mode active, so LACP, in PO1, switch port mode trunk, switch port trunk, allowed VLAN 51, and then mlag. So this would be the same as putting that VPC command, so mlag 1. So show mlag interfaces. We can see we've got mlag 1 configured there. You see detail. Okay. So part of MLAG1, E1 and 2 are members. Good. Okay, so let's jump over to switch 2. Let's do a show MLAG detail first over here, just so we can double check. So yes, MLAG01 is the domain. That's all working. This we will sort out in a minute, like I previously discussed. System ID, and it says that it can see the other side is up and connected. And there is no MLAG ports configured. We will do that now. So int E1 to 2, channel group 1 mode active. In PO1, switch port mode is trunk. Switch port trunk allowed VLAN is 51 to start with. MLAG1, no show, just to be sure. Show MLAG interface members. So, okay, that's better. So now port channel 1 has local ports E1 and E2 as part of that channel. And on the peer switch, as far as switch 2 is concerned, that switch 1 has got E1 and E2 as part of that. So if we look over here again, yes. Now show MLAG interfaces. It is up. Show MLAG interfaces. Up, active, full. Everything all good. Good. So we have got our chassis configuration set up. We've got our MLAG running from this switch and this switch down to switch 3. So if we jump on to switch 3, let me do a show port channel. Can we do a show port channel? Okay, so we can see all the ports are there. Show port channel 1. Detail, there we go. So we can see we have our 4 ports. They're all active. They're all sending and receiving. Show int PO1. We can see port channel 1 is up. Full duplex, 4 gig bandwidth from the aggregation down to that switch. Perfect. Switch 3 is happy. Let's do switch 4. So it should be the same. It's using 3 and 4, 3 and 4. Let's switch 1 first. See if we can remember. So config T, int E3 to 4. Channel group 2, mode active. In PO2, switch port mode trunk. Switch port trunk, allow VLAN 51. Maybe we should see if we create a trunk group and then add the VLANs to the group and send it over. VLAN 51, MLAG 2. No shut. Show MLAG interfaces. Okay. Jump over to switch 2, chassis 2. Int E3 to 4. Channel group 2. Mode active. Int PO2. Switch port mode trunk. Switch port trunk allowed VLAN 51. MLAG 2. No shut. Show MLAG interfaces. So we have our 2 up. So if we show in PO2, port channel 2 is 4 gig, but obviously 2 gigs of it are on this switch. The other 2 gigs of it are on the other peer switch. So that's good. So you can see the active members. So 4 gig. local and the peer ports. Okay, that's all good. So technically, these two should be able to ping each other now. Let's get this third one done first, and then we'll check that we've got reachability across all of them. So let's not. So the final one is going to be a 2 gig trunk using port 5 on each switch. So back over to switch 1. So in E5, channel group 3, mode active in PO3, switch port mode trunk, switch port trunk, allowed VLAN 51, MLAG 3. Show MLAG interfaces. Cool. Next one. Int E5. Channel group 3. Mode active. Int port channel 3. Switch port mode trunk. Switch port trunk allowed. VLAN 51. And then it was MLAG 3. No shut, just to be sure. Show int status. Okay, so we have these ones in port channel 1, these ones are in port channel 2, this one is in port channel 3. We're not using E6. 7 and 8 are part of the port channel 201, which is the second half of the, what they call it again? They called it the peer switch port channel. Okay. Show in PO3. So yes, that's a 2 gig, and it's got one gig member, and the peer has got one gig member. So that is all good. Let's see if we can show interface trunks. Have we got that? Yes. So we're allowing 51 on the 3 downstream, and obviously it's limited, and it allows the other ones. So it's the other way around. So when you do that trunk group, you're limiting that address to that port that has that allowed. So if I was to say trunk, if I was to create a VLAN 52 and then create a separate trunk group and then put that trunk group on PO2, it will then only be allowed there. It won't spread and be allowed down these ones if port is configured to allow all VLANs by default. Because see that that one there is configured to allow all, whereas these ones we've limited there. Okay. Cool. Okay. I think I've got that. Show MLAG interfaces. So we've got our 3 up. So we should now have, if we bring up our test nodes again, so if we bring up node 1, I ping 192.168.51.3. 1, 2, and 3. So I'll send from node 1, I'll send 3. Yes, we've got traffic going. The middle one. And we will ping 192.168.51.1. So yes, so this one is coming up, pinging over to this one. This one is coming up, pinging over to this one. Now let's make sure this one. Ping 192.168.51.2. If I can spell. There we go. Perfect. So we have communication between all 3 devices. Let's just stop that one, then do a, is it IP ARP? Or is it just ARP? I think it's ARP-A. Let's see what it finds. So yep, it can find, it's got the, can build its ARP table. It can find 51.3, which is over here. It is online. It can find 2, obviously there. It knows about itself. It can't find the default gateway that's configured because we haven't configured one. So that is all working. So let's just keep sending the traffic flowing. So we've got traffic flowing across. Let's take a look now at configuring this other heartbeat option and making sure that we don't get the split brain. So that's what we need to do next. And I think we just need to create, so we just need to give it an IP address and tell it what to use. So we're going to use the management addresses. So we already have those set up and we already have a VRF set up for those. So that's fine. So we need to jump back into the, just looking at the documentation. So we need to jump back into the MLAG configuration and configure the peer address heartbeat. So if we do a show MLAG detail on switch 1, switch 1, so I entered the command there, so we can see it is currently, dual primary detection is currently disabled, and what we want to and we have no peer address for the heartbeat. So at the moment all the heartbeats are going over across the port channel interface, and obviously if that gets cut, then by default both nodes will stay active and all interfaces will stay active, and we could end up with a loss of traffic there. So what we want to have happen is we have a separate heartbeat path, so that in the event that this port channel 101 goes down, the heartbeats, they can see that each other is still up, either one of the nodes is still up, and they know to shut down and error disable the interfaces on the device, on the secondary device. Obviously, if like the actual switch was to die itself entirely, obviously you would end up with just one switch online anyway, and the port channels will just handle that traffic because it's the only switch online. The whole purpose of this detection setup is to make sure that in the unlikely event that both switches are online at the same time, but the link between the two of them for the MLAG configuration goes down, then we can make sure that we can stop that from causing a problem. So config T MLAG configuration. And now I do already have, so we're going to use the peer address heartbeat, and it was 10.255.255.2, and we're going to use the VRF management. And now we're going to configure the dual primary detection delay of 5 seconds, action. If it happens, error disable all the interfaces, and that will obviously disable all the interfaces on the secondary. So at the moment it says the dual primary heartbeat MLAG is not receiving UDPs configured. Yeah, because obviously the other side isn't configured. And then again, dual primary recovery. So the recovery delay, we'll put that as, that's in seconds, 30 seconds should be long enough for that. Non delay mlag 30 seconds, non-mlag 0, according to them. Exit, save that, show mlag detail. We can see that it's currently detected. It's the detection is now configured. We have our heartbeat peer address, and we're using the management-vrf for that as our secondary heartbeat. And obviously the peer config is inconsistent because we don't have it configured on the other side. The dual action is to disable all of the secondary interfaces. And obviously, like I said, we won't be able to demonstrate that here, but at least we know we've correctly configured it. So now if we jump over to switch 2, we got mlag configuration. Actually, let's do a show mlag config sanity. So we can see that these are the things that we need to configure on our side. So mlag config, and we are going to do the peer address heartbeat. The peer address is going to be 10.255.255.1, which is the management address. And we're going to do that over the management-vrf. So that does that. And then we configure the dual primary options. So detection, delay of 5 seconds. And once you detect it, the action is to error disable all the interfaces on the secondary. When we recover, so the dual and recover, the delay from that will be, for the mlags will be 30 seconds, for non-mlag 0. And that, did we do a reload? What was the reload delay? Where's the full config? Reload delay of 120. Yeah, we did that already. So, yep. So exit show mlag configuration sanity. Everything's all consistent. Save that, show mlag detail. So we now have full mlag set up. We have our mlag and our port channels all working. We have intercommunication working. We have our VRF for our management. We have our secondary heartbeat setup. We have our dual primary detection setup, so there's no chance of a split brain scenario. And now everything's working. So this is all done from as far as the Arista configuration side. Now let's just take a quick look at what the failover times are, what happens if like a whole switch dies. So we know at the moment over here, we've got traffic coming from the node here. We're sending it up both of these legs towards switch 3 and down into node 8, and obviously back again because we're getting a reply. Let's have a quick look at what sort of traffic is going across these interfaces. So if we do a capture, let's have a capture of the port channel interface that's going in between the switches for the chassis. Let's take a look and see what sort of traffic is like across there. So we can see we've got some, let's let that capture for a second. Okay, all looks the same. So if we take a look, we can see we've got some broadcast traffic. Okay, so it's sending ARPs across there. And then the rest of the traffic we can see is TCP between the two chassis. So 254.1 is the left, 254.2 is the right. So they are communicating with each other using TCP for the multi-chassis setup. So we can see we have that traffic. We have UDP traffic going across that link as well. That's obviously the heartbeat traffic for one of the communication paths. Obviously, we'll take a look at the management interface as well in a minute. So it's broadcast traffic and inter-chassis heartbeats and inter-chassis TCP communication, obviously for for the ability for the MLAG to function. What else do we have? We have some LDP traffic, obviously some standard. Yep. Okay, so we have some LLDP. Obviously, this is not a Cisco device, so it's not using CDP. So obviously, yes, we have some LLDP, so we can see what our neighbors are. And like I said, we've got our TCP traffic for that. And then, yes, see, we've got heartbeat communication between the two devices using UDP. So let's quit that. Don't want to save that, so we can quit. Let's have a look at what's going across the management interface. So if we capture on the management side, we should probably see pretty much the same. So 2551 to 2552. So again, we have secondary heartbeat traffic going across the management between the two devices. We obviously have spanning tree running because obviously we've got those ports connected to a switch. Again, we've got some LLDP traffic and the rest is heartbeats at the moment. Obviously, if we were using, say, the management machine to send ping traffic to these or whatever else, this would show up because it's all in part, all part of that that single subnet. So obviously, yes, it's secondary heartbeat and LLDP and some ARP for the rest of the management network. Cool. Let's now take a look at one of our switches. So let's capture one of these interfaces, E1, which will be coming from switch 3 coming up. We can see that we've got the traffic being sent from 51 to 53. Obviously, it's not seeing the response on that leg because obviously it's coming back via probably one of the other channels. So if we capture, let's capture Ethernet 2. There we go. We can see the same traffic, the reply and the request traffic going backwards and forwards. Okay, let's exit that. So we can see that we've got traffic coming across our port channels there. Let's go and take a look at switch 3, where we've got the traffic coming down. So if we look on switch 2, we'll capture E2. So we can see broadcast traffic on there. Let's have a look at E1. Oh, E5, sorry. Capture E5 is the one I want to capture. And there we go. We can see our traffic coming down towards switch 5. Perfect. Okay. Okay, now let's check from our management desktop that we can reach all of our devices. Just to be sure. 10, 255, 255.1. Oh. Yes. 2552. Yes. 3. 4, 5. Perfect. And the management switch there is 11, and we ourselves are 10. Perfect. So management network all working. Inter-rack traffic for our 3 nodes working, coming across the multi-chassis setup, the aggregation. Right, so now let's see what happens when we drop a switch. So at the moment we know switch 2 has got the lowest MAC address, so it's set as the primary as far as the multi-chassis lag setup is operating. So we're going to switch this one off, and what we'll see is we'll watch to see what happens to the traffic. Let's stop switch 2. Let's have a look at our traffic flow there. That's stopped. Let's bring up our window. Show MLAG detail. And there we go. We can see that the dual primary heartbeat is down. So it knows that the heartbeat is down across the peer link, and it knows that the heartbeat is down across the management-vrf as well. So that is down. We can see traffic is currently unreachable. It's obviously going through its process. Show detail. State is still saying it's the secondary. It's still saying that it's active. It's obviously trying to connect. Obviously the other node has died. Let's do a show MLAG interfaces. They're obviously still reporting as up. So we've obviously waiting for timeouts to happen. There we go. I can see traffic coming back through again over here. So Control Z. 48 packets dropped whilst we lost an entire switch, and then obviously we come back up. So let's do show MLAG interfaces. There we go. So we can now see on switch 1, it is now an active partial. It knows that the local is up, and obviously the remote, it's got no status. Show MLAG detail. So the state is primary. It puts the peer state as primary as well. Okay. Peer link is down. Hardware ready, true. Failover, true. The cause of the failover was a peer link down. It happened 36 seconds ago. Good. And we have active partial ports now instead of active full. Okay, so now if we do a show int PO1, there we go. We can see our traffic has dropped to 2 gig, whereas before it was a 4 gig. Perfect. Okay, let's bring this one back up and see what happens to the state, whether or not this one stays listed as primary and this one becomes secondary. We'll have a look. And then we'll move on to trying to replace one of these cabinet switches down here with a Juniper switch and get at the very least the access interface and the trunk configured up towards the distribution and the management VRF, etc., and remote access via SSH to the device via the management interface. So that's the next goal. So let's wait for the switch 2 to come back up online, and then I'll come back when it's back up online, and we'll move on to our next task. And there we go. Right, to save us some time, I have pre-added our Juniper switch. I have, again, like we did at the start, created node 9 and given it an IP address that we're going to use in VLAN 51. I've connected the switch's management interface to the management network, and I've configured and I've connected 2 Ethernet cables from the Juniper switch to our Arista MLAG cluster. So let's do the setup that we've just been getting used to on the 2 switches, and we'll create the MLAG down to our switch 6 in the new cabinet. And we will then come over to our Juniper. We'll create our trunk, our management VRF, and our access port, and we will set up our username and password, our backup username, and secure the default username. And then we'll check that we can reach it from our management network, and we'll check that our other devices can reach this device that's behind a different vendor. So all in all, by the time we finish this video, we have got Cisco switching, Arista switching, and Juniper switching. So all in one shot. So let's jump on to switch 1 first, and switch 2, and create our MLAG. So show MLAG interfaces. So we can see we have 3. We are on port 6. So config T, int E6, channel group 4, mode active, int PO4. Switch port mode will be a trunk, and the switch port trunk allowed VLAN will be 51. MLAG will be 4, no shut. Okay, so we can see we've done our configuration on the first Arista switch. Let's do the second one, admin. And show MLAG interfaces, int E6, channel group 4, mode active, int PO4. Switch port mode is going to be trunk, switch port trunk, allowed VLAN 51, and we will make that part of MLAG 4. Exit, WR, show MLAG interfaces. So there we go. So we've got our new MLAG configured, or our new port channel down to our Juniper switch, configured on both of our Arista switches. So that is done, saved, perfect. Now we've done our configuration this side. Now let's work over here on this one. We've got a different setup to do now. Let's bring this in a little bit so we can see what we're looking at. Move me up here. So we are looking at interfaces GE001 and GE0/0/0. Our access port is going to be GE0/2, and our management interface is going to be that. So I'm going to try and see if I can do as much of this. So root is the default, CLI. Now, what have they got here? So they've got a delete chassis auto upgrade. So we'll do that so we don't get bombarded with any of these auto reminders. We'll commit that. It'll probably tell us that we can't. So we will do the next thing that it wants us to do. So we will edit system, and we will set our root authentication, plain text password. I really wish it would stop doing that. Null zero labs. Now we should be able to commit, because it won't let you commit until you've got the root password set. So there we go. So we've done that. Now, how do we set system? How do we set the host name again? Set system host name. There we go. Host name. And this is SW6. Commit that and we should see it change. There we go. Root at SW6. So the host name's gone in. So we've done that. Let's create our other user that we had, our backup user account of Null Labs. So we are going to edit system login. And we're going to set our user. The username was null0labs. The class is going to be a super user, and that's similar to doing the privilege 15. We've done that, and then we want to set the authentication plain text password, and we'll do null0labs, null0labs. So we can see under the edit system login section, we've now added the user null0labs. It is a super user and we've set its password. So we've done that. So we've set the root password. We've created our admin password. Let's set the services. So edit, let's go up one. Edit services, set SSH. And that should be that. Go up. Now let's sort out our management interface. Our management interface here is FXP0. So VRF is what we're going to be looking for. How do we do that? Documentation. Let's have a look. Management interfaces. We give it address. We create a routing instance. Okay, let's edit that then. So up, let's edit interfaces, set FXP0, and we're going to set unit 0, and it's iNet family from what I remember. Family iNet, that's the one. And we will set an address, and it'll be 10.255.255. And we used 1, 2, 3, 4, 5. This will be 6. I do a /24. Yes. So that's the address. Up. Let's commit. Oh, so there's now error with DHCP. Okay, show system interface or show interfaces. Oh, so we've got this DHCP option. So edit interfaces, delete FXP0, family unit 0, family iNet DHCP. Commit. Okay, so that has created run. Let's remember. Okay, so run show interfaces ToRs. There we go. It's got an address. Now we need to pop that into a VRF. No, system. Management instance. Management instance. Now what can we put under that management instance? So set management instance, this creates the management JunOS routing instance and moves FXP0 into it. So that's done automatically. And now we just need to create a routing instance or use that routing instance for the default gateway. So show, actually, if I go up to the top, if I commit that then. Now if I show again, so routing, okay, let's edit routing instances. Okay, and then let's set, what is it called? MG, what did you say it was called? MGMT underscore JunOS. And we'll set the routing options, static. We're going to do a static route. So route, and it's going to be 000/0. And the next hop will be, we said was 10.255.255.254. That accepted that. Commit. Run, show, route. Okay, and there we go. So we have the management routing instance. And it has the static route, and the FXP is part of that instance. So it's separate. Perfect. So we've created, so far on the Juniper one now, we've managed to do the host name. We've set the management IP address. We've put the management interface into a VRF. So if I, and with, what else have we done? We've added our backup username. So now let's do a test. Let's exit out of here so that we are not in edit mode. Let's ping. Do we use VRF or instance? So if we ping using the interface FXP 0.0, and we want to ping 10.255.255.1, and we can. Good. So the management interface is up. It can reach the Arista management interface 1 and 2. It can reach the management desktop down here as well. So that bit's all good. So back into configuration mode. The list, we need our VLAN. So I'm hoping that should just be set VLANs. Or should we just edit VLAN? Edit VLAN and set VLAN. Oh, VLAN name. Set VLAN 51. VLAN ID. And we will be 51. The VLAN 51 has a VLAN 51 ID of 51. Interface. So let's go up again. Let's edit interfaces. Let's set, what interface was it? G02 to unit. Oh, there we go. Unit 0. This is going to be Ethernet switching. So family, Ethernet switching, VLAN mode. Is it VLAN mode? Switching. Family Ethernet switching. Interface mode is access. VLAN was members VLAN 51 show. So 002 interface mode is access, VLAN members 51. That looks correct. Okay, so now we need to do our trunk interface. The chassis aggregated devices. We want Ethernet. Device count. We only want one. That should do. We will then set our interfaces. What do we say? GE -0/0/0. Ethernet options is 802D, and we'll assign that to AE aggregated Ethernet 0. And we do the same for GE001. So that's putting them there. We then set interfaces AE0 as aggregated Ethernet options as LACP active. So that should be enough for that. And then we will then set the trunk and the thing. So that should be the same. So that should just be set interfaces AE0, and it was unit 0 switch family was Ethernet switching, and interface mode was a trunk, and then the same, but we went the VLAN members was VLAN 51. So now we should be able to commit that. God, it's been a long time since I've had to type Juniper syntax. I'll have to start doing it more often. So if we do a show, we've got our root authentication, our extra user. We set up our SSH. We've got our management instance. We've created our aggregate Ethernet interface because we're only using one. If we are, from what I remember, if we have another one, we update this account with say 2, and then we'd use AE01 for the next one. We've then done a similar scenario where we've put G00 and G01, that we're going to be using those as part of as the physical devices for AE0. And then we've then come down to AE0, and we've done that it's a LACP aggregate interface. And then again, under the unit 0, we've said that this is a trunk interface, and we've said VLAN members 51. So that, and then we've created our routing instance. So if we ever did have a management network that was outside of 10.255.255.0/24, we can reach the devices, and we created our VLAN. So let's make sure that's committed. Let's exit. Now we should be able to jump to our test machine. This is the one that's connected all the way over here to switch 3. And we now want to see if we can now ping to node 9, which is IP4. And we can. So we can ping that. Let's do an ARP-A. Make sure that's working. Let's jump onto node 9. Just to be sure. So null 0 labs. First 123. Ping 192.168.51.1. We can ping that. 51.2, we can ping that. 51.3, we can ping that. And obviously, because we set up a VRF for all of our management stuff, 10.255.255.1, we cannot touch. That's all good. We can't touch the management desktop. It doesn't exist. Perfect. So we have communication between our 4 cabinets. We have our multi-chassis lag so that we can have LACP port channels between different switches. And we have 3 different vendors of switches for our setup in our cabinets. We have Arista and Juniper. And for our management switch over here, we have our Cisco switch. Finally, let's just jump onto our management desktop, see if we can reach the management interface of our Juniper. So if we open a terminal on here, and we now go, hey, ping 10.255.255 what did we say that was? 6. There we go. We are getting a response on the management interface. If we SSH null 0 labs at 10.255.255.6 null 0 labs. We are in. There we go, JunOS, and that's because we are just a standard super user and not root. We are dropped straight in from memory. And yes, we can show the configuration. Show interfaces. Show interface AE0. There we go. So physical link is up and speed is 2 gigabits per second. So perfect. And so if we log out of that switch, we can log out of that switch from our management desktop. So there we go. A bit of a longer one than usual. It was more that I wanted to use this video as a quick memory refresher on Arista and on some of the Juniper commands, because it's been quite a long time since I've touched a Juniper device. So trying to remember some of those required some looking up. But there we go. We have a simulation of 4 cabinets now connected to the end cabinet as the distribution point, and we can increase the bandwidth to each of the cabinets. Each of these nodes that are in VLAN 1, VLAN 51, sorry, are communicating with each other across that fabric. And we also have management access to all of our management interfaces within a separate VRF, so that that traffic is completely isolated and separate from the traffic that's going across the top. So I hope you found that useful. If you did, please hit the like and subscribe button. We're getting close to about 900 subscribers now. It'd be great to hit 1,000 soon. And I will see you on the next video. Thank you very much for watching.